Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, November 21, 2025. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a cool and cloudy autumn evening here in my hometown of Rockport, Massachusetts. These Earth and Space reports are intended to engage, inform, and inspire people like you who are curious about Earth as a planet, who care about our life-sustaining biosphere, and who wonder about the greater cosmos and all that it has fostered throughout space and time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access cable television channel. I'm grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, myriad Earth and space scientists, educators and communicators, far-flung friends, family, and other curious folk. Thank you for your active participation and encouragements. This evening, I'm most pleased to be hosting a fellow science writer, Megan Watzke of the Harvard Smithsonian Center for Astrophysics. But first, I'm going to get, where'd he go? Tony, there you are. Tony Weinbeck to show us some of the aurora photos that he took in Wyoming, which is where he is. So, Tony, why don't you take it away?
Hi, I'm very sorry, Megan, to hijack your presentation, but I am in beautiful Wyoming right now, and the sun is just setting right now over our observatory. Like I pointed out, it's right there, right at my fingertip. We're at almost 10,000 feet at the observatory. And I just wanted to show, so during the auroras last week, I went up in the mountains. I was at roughly 8,000 feet here. So this was just as everything started to go. More specifically, this was, I was able to see the first impact from lower elevation, and then I drove up to the mountains, and I set my camera up just as the second impact hit. So
Hmm.
it really exploded.
Wow.
And the camera, this is a very super wide angle lens, and it didn't do it justice. A 14 millimeter angle lens. So the whole thing was just it was a trip to see.
Wow. Looked very bright.
Yeah, and the whole sky was absolutely illuminated, two-thirds of it. And at one point about this here, there was just a big arc hanging over the southern hemisphere, or the southern horizon. Um, it was unlike anything I've ever seen. So anyway, I just wanted to show you all. So that was my experience with the auroras here. So thank you for indulging me.
Wow. That's beautiful, Tony. Hurrah, hurrah.
So once in a
Um,
lifetime.
Yeah, once in a lifetime. I did catch the end of it, and it was just a very enjoyable rosy glow for me. That was at 11:15 once I peeled myself off the couch.
That would have been the first impact here that I saw, actually. So, yep.
Okay. All right, so on to Megan. Megan has been a science communicator for nearly 3 decades. In her day job, she has served as the press officer for NASA's X-ray Observatory since 2000. Along the way, she has co-authored a half dozen popular science books. Her latest, Why Space Will Freak You Out, which is from Sourcebooks, will go on sale this coming February 10, 2026. You can learn more about these books at her website, arkandwatsky.com, whose URL I will put in the chat. Tonight, Megan will regale us on the worst places in the universe. While space is indeed full of sublime wonders, this talk will not be about those. Instead, we will figuratively journey to some of the scariest, creepiest, and grossest places in the cosmos. You may wish these horrible space destinations were the stuff of fiction, but alas, they are fully real and described to us through data from the world's most powerful telescopes. So let's get going. The Zoom platform is now all yours, Megan.
Oh, thank you. Well, thank you, Bill. Yeah, so I will give you guys an introduction to this book that I co-authored with Kim Arcand, who I've written almost all of my books with. And I can give you a little bit of a reason for why we decided to do this book. Um, you know, I there's just so many astronomy books out there, and I've written a few myself, and they're always about, the awe of the universe and the wonders, and it's all true. But one, you don't want to reinvent the wheel, right? I mean, those books exist, and you've got some very famous names attached to them. And two, this is our first foray into a kids book, and I think that kids and adults are often intrigued by sort of the darker side of things, some scary stuff, gross stuff if you're a certain age. So we kind of tried to lean into that a little bit with this book. It's the exact age range is, kind of fuzzy. I think middle school and up is the idea. But, we're hoping that interested adults would also pick it up because while we do have this angle of it being, sort of for kids, it's really, we hope the information in there is something that you can read of any age. So you're trying, sort of imagine Lemony Snicket's for astronomy. It's kind of that, maybe with a little dash of Stranger Things thrown in. So this is, I think I can share. Let me try. I can just show you the cover. Let's see. Share, share. Oh, hang on. It's not letting me do this. Yeah. So, of course, technical difficulties. Um, may not record it. I'm gonna have to leave the meeting, come right back. So talk amongst yourselves. Hang on, it's making me reboot. I'll be right back, I think. Hopefully. If not, I'll
Well,
be
the
back.
cover is very evocative, and I think it will work well with kids. I'll probably put it on as uh, the beginning of the YouTube recording, so that people can see it right off. So join us. So she's now in a waiting room. Oh, I gotta let her in. Okay, okay.
Sorry about that. You'd think I could do this without, breaking my computer. But let's try again. Okay. Can you hear me?
I can hear you.
All right.
Don't see the share yet.
Okay, let me try
Oh,
this.
here it comes.
And let me try this. And that. You see my screen now?
Yes.
Okay.
Yeah, that's a fabulous image.
That's not real. That's an artist illustration. We won't find that picture somewhere. So this is a cover, obviously. And again, it's kind of meant to, be a little counterintuitive as far as like getting kids in particular interested in space. And the format of the book is really easy to follow. We break it down into three sections: solar system, galaxy, and then beyond. So the solar system one, I threw in a few examples, but this is what one of the pages will look like. I don't know how many topics per section, probably 8 to 10. But we've tried to take some of your more familiar objects like Mercury, which, again, most kids know that it's the closest to the sun, blah, blah, blah. We tried to tease out what would be kind of creepy or scary about it. And so we include in all of the sections real data images because I mean, again, while the tone is meant to be kind of fun and lighthearted and with a dash of creepiness, it's meant to be also informative. So all of the sections have both these fun illustrations that were done by not me or Kim, illustrator that the publisher found, but they also have data images from the most powerful telescopes we have. So this is kind of how the pages look. So I mean, we just kind of went through where we thought would be kind of the grossest things, like Io, for example, and the rotten egg smell, like we kind of creep kids out a little bit.
Hmm.
And Saturn, that one's about falling forever if if there's no solid core, most likely. And Titan, we talked about sort of it looks like it'd be a great place to be. Obviously there's lakes are not water, they're methane, and it would kill you. And Enceladus is maybe has water, but you'd be frozen under an icy tomb, and just so on and so forth. So that was kind of, let me see if oh yeah, here's a picture of Io that we include in the book to talk about sort of the geysers and also the volcanoes and all the things that would be kind of gross to be there if you were lucky enough. So then the book takes you throughout the galaxy, and the galaxy one is mainly what we've learned about exoplanets. And
Mm.
clearly, this is an illustration of, to give you an idea of, I mean, there's we just passed the 30th anniversary, I think, of the discovery officially of exoplanets. And then, we have what, 6,000, I think, now that we know about. And some of them are super weird. And I think that that's kind of an element that kids and adults hopefully will find interesting because they don't look like the vast majority of them anything like Earth. And so that's a good thing. Sometimes it's also can be a creepy thing if you pick the right ones. Like, we talk about the poltergeist planet because it's a planet that they think is formed around a neutron star that survived a supernova, so it has this sort of zombie star kind of thing going on, or TRS-2b, which is the planet that would be is absorbs about 99% of the light from its host star, so it'd be completely dark. So that we thought that would be kind of a fun, kind of creepy thing. I should say we wanted to walk a line between talking about the scariest places in the universe, but without freaking kids out. I mean, I think some people have a legitimate fear of some things, and we tried to keep it sort of light, and not put anything into someone's head that will give them nightmares or places that they can't want to look up to the stars. I mean, the idea is to get them hooked with this angle, but not turn them off. And hopefully, we've found a balance, but we'll find out when kids get to read it. So,
Mm.
yeah. So this whole section is mainly about exoplanets. We do have Etta Carina in there too. We call it a glowing, exploding brain in space because that's what it looks like to me. Of course, it's not going to really do anything to us, most likely. I mean, if it goes off, but a space brain is, I think, something that might get someone intrigued. And then we also talk about the Crab Nebula. We talk about Sagittarius A star and how there's this giant black hole at the center of our galaxy. I mean, these are a lot of things that if you're in the astronomy world, you kind of take for granted that people know, but they don't. And some people may or may not, be scared of a 4 million solar mass black hole, in our galaxy. But then you explain that, it can't hurt us. It's, 26,000 light years away, all this stuff. The idea, again, is just really to hook people's interest in a different way. So here's Sagittarius. I don't think this
Mm.
exact image is in the book, but we, use all of these things. So the final chapter is anything beyond our galaxy, or a section, I should say. And here we kind of just, again, sort of explore what is well known in the astronomy world, but maybe not so well known in the non-astronomy world. Like we talk about Andromeda on a collision course with Earth, and what that would look like, and that sounds awful. But of course, the punchline is chances are we'd be fine because space is so vast and empty, we'd pass right through each other. But it sounds creepy and it sounds scary, and maybe that gets people interested enough to go and learn more about it. We talk about things like this is the bullet cluster. So towards the end, we talk about dark matter and dark energy. Again, two very different things, but having the universe be dominated by things that are unseen and to a large extent unknown, I think that can be pretty, um, you know, sort of scary, or again, attractive if you find that kind of mystery interesting. So we also, that last chapter talks about spaghettification and falling into a black hole with tidal disruption stuff. We talk about gamma ray bursts and what would happen if one was really close by and pointed at us. We talk about magnetars and what would happen if we were influenced by a super powerful magnet like that, and a couple of other sort of, interesting to us examples. So I don't know if I have anything else. So I don't think I do. Oh, wait, this is a trailer that I forgot I threw in here. Our publisher did this right before Halloween. It's not on sale yet, but I thought it was kind of fun. So that is really, I don't have a long presentation because I wanted to make this more of a discussion, but That trailer, by the way, we asked them to put it together, or they were thinking about it because obviously this is the kind of thing that maybe be fun to play up during Halloween, or some of these other times when I don't know people are it's sort of holiday spirit. So the book isn't on sale yet, so maybe for next Halloween. But they did put it together this year, so we'll hopefully dust that off for next year. So yeah, I mean, really, this is just kind of like one of our many attempts over what is now a 3 decade long career that I've tried to make astronomy in particular, but like science in general, as accessible to as many people as possible. It, Overall, not to get political, it seems like we're going in the other direction. So I don't know how
Mm.
successful anything of this has been, but I still keep trying. It's very much sort of the motivation behind my career, which is to make science ingrained in the fabric of our society. So yeah, I mean, I'm happy to answer any questions about the book. I can also happy to talk about my day job at Chandra, which is where I've been since 2000. Before I am at the Center for Astrophysics, but that is operated, which is the center that operates the Chandra X-ray Observatory on behalf of NASA. So Bill was right. I'm there, but I'm also with NASA as well. And yeah, so if you want to reach out to me, there's my contact information. But I will stop sharing and let see if there's any questions. If I can stop sharing. Let's see. Hang on. How do I stop sharing?
Probably down at the bottom of your.
I got it. I think. That work?
Nope. Down.
Hang on.
Is it the green? Is it a green or red thing down at the bottom?
Bill,
Okay.
you can do it from
Okay.
the
Got
top
it.
of the screen.
Got it.
There you go.
All right.
Thank you,
Thank you
Mike,
very
for
much.
reminding me of that. Well, I have lots of questions, but I'm going to open the floor to anybody else who has questions. Andrew.
I have a question, which is what a great idea, first of all, for a book. Um, is Megan still here?
I'm still here. Yes. Thank
There she
you.
is.
Well, thank
Okay.
you, Andy.
All right. And I wonder if you have a 15 to 18-year-old social media person to help you get the word. I mean, this is the kind of thing that should be on TikTok. It should be all over the social media that kids read. Are you guys doing that, or do you have a consultant in the younger age group that can help you?
Well, I have 4 kids, and two of them are 18-year-olds, and a 12 and
Boom.
a 11 and a 13-year-old. And Kim has 2 kids. So we will get professional advice because it's not going to be me. I don't know anything about this stuff. And then the publisher has a plan for, so I do not a
Okay,
lot of social media stuff. But yeah, the idea is to, figure out how to reach those audiences. And it's probably not through the ways that I would do it because I'm ancient and they don't, so yes, we will definitely ask for help with that stuff once it's on sale, but even before.
great.
Arthur, that was a Bible for me.
What's that?
Um, yes, that right there. So Sir Patrick Moore's Atlas of the Universe was what I grew up with.
My brother gave it to me as a gift recently. It's a wonderful read.
So I'll ask one question. What age group are you targeting? Or
I mean, it's really written for probably like middle school and up. I mean, I think some upper elementary school kids could definitely read it and understand a vast majority of it. But when I was writing it, we were writing it, it was mainly, not super young, not early elementary. It's not a children's book. It's more middle reader, I
Mhm.
think. Um, and again, super tough to like figure out what that means. I don't know because every kid's different. So, and again, part of the motivation was we wrote another book called Light about explaining the different kinds of light a bunch of years back. And we found sort of anecdotally that it ended up going into Scholastic and schools ended up using it. And that wasn't the original intention, that we thought it was more of an adult book. But I tend to try to write things in a way that I have a brief attention span, maybe. I don't know, that it's short to the point. And so I think some schools ended up using it. And we found that kids were reading it with their parents or passing it back and forth. So
Hmm.
that was kind of the motivation to some degree behind this one, which is to write it in a way that hopefully multiple age ranges could understand, or appreciate. I mean, obviously people understand it, but like, you
Mm.
know, so that it doesn't really have a defined age range in my mind, but you got to put it in somewhere for these publishing types. So middle reader is what I would say.
Mm-hmm. Um, Michael.
Oh, I
Hi.
hi. Look, I'm sure you've responded to and probably debated this 1,000 times prior to publication of this interesting thing. But isn't this in some part not unlike trying to get kids to come to the library by telling them that there are people in there that are going to kill them?
I mean, not exactly. I mean, I put it more in the entertainment genre of like Lemony Snicket's or whatever, where there's an element of scariness to it, but at the end, you're totally, the kids are gonna like the kids in that story are fine, and that's really where, it's not a slasher movie or in book form or anything like that. Um, we're not trying to scare kids to death. We're trying to scare them into, you know, being intrigued. And so we did try to walk a line, and there were some things in there that we ended up like tamping down so that kids wouldn't go home and be like, wow, or put the book down and be like, I'm really freaked out. It's more like in a lighthearted,
Mm-hmm.
way. Well, I hope that's the hope. We're trying not to go for too cheap of a thrill here, but I think that it's something that was counterintuitive. There's again so many books about how great space is and the wonders of the universe, and Tyson and it's obviously Sagan, they've all done these things and it's all true. I just didn't want to do the same thing again. I want to do something that was different and
Mm-hmm.
maybe capture people in a different way, hopefully.
Yeah.
Cool.
I think it's enlightened, not frightened.
Yeah. I mean, that's sort of once you get them hooked and pick up the book, hopefully they're learning something and want to learn more.
Well, there's a whole psychological thing, with the child development, which you probably went over in your brainstorming. But there is a period of time, when I've given public presentations which had kids there, and I'm talking about, flares from the sun and things like that, and or an explosion or something, and they are, below a certain age, they are freaked out,
Hmm.
because they think it's going to happen
Hmm.
to
Right.
them and their family.
Well, and there
But
are people, there
have
are
to,
adults who think that too if you talk about it too much. You know what I mean? Like, and that's part of the, you know, you want to educate people to the point where they understand the context of these things. Like, yes, the sun does erupt,
Mhm.
but most of the time we're fine. But it can't. You should know that it does, and it's okay. But I do think that it depends on your background. But yes, some kids are, you know, uh, would at a certain age would not might really be freaked out. I think this. I don't know if you guys are familiar with the Goosebumps series, like sort of that kind of scary, but not, at the end of
Mhm.
the day, not like, goosebumps for astronomy kind of thing. It's not meant to horrify or, be,
Yeah.
debilitate anyone. It's meant
Well,
to be kind of a fun, lighthearted, scary-ish take on something.
yeah, yeah. Above a certain age, maybe it's 5 or 6. I'm not really sure.
Yeah.
Um, those sorts of things, the scariest things, end up being cool. There's a
Yes.
coolness
That's what
factor.
we're going for. Not,
Right.
not
Like the
not the scare.
conduct book on icky things like snot and those things. There are theme books for children about disgusting things
Yeah.
that are just for fun,
Yes.
and I'm sure it doesn't get a lot deeper than that with this. I just thought it's something you had probably had to talk through with the publisher at some point, and I was wondering what the other side was. So very well.
Oh, Patty has a question.
Or where is that? Um, a friend of mine is the children and young adults librarian at a library in Bridgeport, Connecticut. And she just loves discovering weird stuff like that. And what I'm curious about, because I had to ask my brother about this when I learned about it, I feel all better now, is something like Andromeda and the Milky Way And the fact that they're not actually going to crash into each other. Is that explained?
Yeah. Yes. I mean, in that section again, this is these are short coverages of these topics, right? So we don't get into a lot of detail, sort of by design. But yes, we explain that they are going to collide, but space is vast, so most of the individual stars and planets will pass through each other eventually over billions of years. That's the other thing about these things. Either these things are really happening, but they're on either too far away to really affect us, or they're in such large timescales that we don't need to worry about it. Like the Andromeda Milky Way collision will be in maybe 5 billion years. We have some time, And so that was the other bit that we made sure that we were reassuring kids in throughout the text, like even if you find this like a terrifying idea, and hopefully they aren't really scared, it's not going to happen in our lifetime. It's not going to happen in any of our probably humanity's lifetime. Um, but yes, we do try to explain that, in something like that, it sounds scary, but really in the end, even if we were around to experience it, we'd be fine, and most likely.
Actually, Patty, it's going to be like two armies throwing eggs at each other forever and ever. It's going to be horrifying.
I love that. Thank you, Michael. Well, that's great. I'll definitely let Bina know about it. I think she'll get a kick out of this book.
Great. Thank you.
Tony, don't forget to unmute.
Yep, thank you. So yeah, Megan, that's it looks like an awesome book, and I'm especially stunned by the visuals. And I think that combined with the hooks that you're pulling in for the stories that you're creating, I think that's going to be, like who can't be interested in that when they see the book. So like, great job there.
Thank you. I hope you're right.
So I guess my one question on a very different topic, you said you work with Chandra at CFA. Could you tell us maybe your one or two most exciting discoveries related to Chandra in the last year?
Oh, in the last year.
Ish.
Sure. I mean, the last year has been, as you guys probably know, a bit of an up and down with the budget for Chandra. So a lot of our effort has been to save, to make sure that we are still intact. And we are. The telescope is, for those of you who don't know, Chandra is NASA's great observatory for X-rays. So it was launched in 1999. So it has been in space since 1999 and is still performing remarkably well. And, it has some spacecraft issues, but the engineers that work on Chandra figured out how to make it just as efficient, if not more efficient than it was earlier in the mission. There's some limitations, but other than that. So yeah, so in the past year, I mean, we did we do a couple stories a month on recent results. I personally like all the results that where Chandra is applying itself in fields that didn't even exist or weren't really fully known about when Chandra was launched in 1999, like exoplanets. And we've been able to use Chandra to study the effects of stars and flaring onto planets and how that would determine habitability and all sorts of things with the host star. So there's that. We've had this year, off the top of my head, let me just refresh my memory of what the names of these things are. But we've had a bunch of results as usual about black holes. I mean, if Chandra is anything, it's the black hole finder and studier. We found one that was very, very, very massive at the very earliest part of the universe. And so along with a telescope like James Webb, you combine data from these two telescopes together. And that was probably one of the most interesting ones of late for me, which is to sort of figure out like the chicken and egg thing of what happened first. Like was it the galaxy? How did the galaxies form, and how did the black holes form within them? And there's different competing theories. So Chandra has had some pretty interesting results, in particular lately, about the detection of very early black holes, like only a few 100 million years after the Big Bang. So stuff like that, it continues to perform really, really well. So there's just a couple of examples from this past year. I don't know if that's specific enough for you, but
Are
That's
those
awesome. Thank you so much.
are those the red dots that
Not all, no, they're those are there too. And Chandra is looking at those, but this is in particular like it's about a year and a half or 2 years ago. There was a very distant black hole. I'm forgetting the name. I remember that it's just a singular black hole that is JWC found it, and then Chandra follows up to find the signature for the black hole. So it's not just it's more of a direct evidence that it is in fact a black hole, not just a distant galaxy. So the
Hmm.
little red dots are still a work in progress as to exactly what they are.
Hmm.
Was Chandra able to look at anything related to the black hole collisions that were recorded by our interferometers?
Are you talking about the gravitational wave stuff?
Hmm.
Yeah.
Yes, actually, the one in, so was it 071807, I think. It was the first one that where there was a gravitational wave signal, and then there was follow-up with electromagnetic spectrum results. So Chandra was part of that back in 2017 or 18. I think it was 17, when they announced it. So yes, we can see the aftermath of some of those events. Some of them, a lot of them, no. But we do often look to see what's going on.
What does an image like that look like?
Pretty much a dot, it's a detection. A lot of Chandra things are, Chandra can make great images of certain types of objects, like supernova remnants, things like that. But a lot of times the real science, meat of the story is the image is not necessarily spectacular. In the case of something like that, it's a dot, probably.
It's hard to capture X-rays.
It is very hard to capture X-rays. And Chandra was that's part of the engineering marvel of it is that it can capture X-rays and focus them and produce images at all, but let alone very high quality. But yeah, it's hard. A lot of these things give off a handful of X-rays, so then you're really photon limited, as they say.
Hmm.
Wow. Thank you.
You're welcome.
In your slideshow, you showed one picture which demonstrates the existence of dark matter. I think it's in a galaxy cluster,
It's the bullet cluster.
the bullet cluster.
Yeah.
And if you could explain that a little bit more, I think a lot of us would be most appreciative.
Sure. I'll see if I can bring it back up. That might be easiest. Let me see if I can
Because
do.
that's, quite a find.
Yeah. So where's my bullet cluster? Hang on a sec. So this is
There it is. Yeah.
okay. The bullet cluster. Is that showing? I
No.
went to,
Not yet.
okay, hang on. I went too fast.
There you go.
All right. So this is actually the bullet cluster 2.0, so to speak. So back in 2005, I think it was, maybe, um, we had an original bullet cluster image, which this system is officially known as something else, but nicknamed the bullet cluster because it looks, in the pink at least, it looks like a bullet traveling to the right, like those stop motion images that you see sometimes of a bullet going through an apple or creating a wake behind it. And so what this picture is actually an updated version that includes data from JWST in addition to the original, which include Chandra data and X-rays and Hubble data. So what this image represents is that the pink is the hot gas observed by Chandra, and the blue is the gravitationally lensed map of where most of the matter is. And the bullet cluster is one of the systems where is indeed a giant collision happening, but instead of individual galaxies, it is two galaxy clusters that are colliding. And as you guys probably know, galaxy clusters are the biggest objects in the universe held together by gravity. So you have thousands or hundreds or thousands of individual galaxies, but what weighs more than all those things added up is the hot gas that pervades them. These galaxy clusters are bathed in giant reservoirs of superheated thin
Awesome.
but superheated gas. And that's what Chandra sees. It sees the hot gas, and that's one of the sort of bread and butter objects or class of objects that Chandra looks at. So this bullet cluster is two clusters indeed, in fact, passing through each other. And what happened when those two clusters collided was that the energy involved was so great. It's one of the most energetic events since the Big Bang that it separated the hot gas, which is the normal quote unquote mass, from the dark matter, which is represented by the blue. And we know that the blue is indeed where most of the mass is because of the distortions of the distant galaxies through gravitational lensing. So you can map out where these things are. So this was really, back in the day, this was one of the first direct and most powerful pieces of evidence for dark matter existing. So it's kind of iconic in the astronomy world. And so, we used it to illustrate this concept in the book. Does that explain
Yeah,
it?
that's good. And correct me if I'm wrong, but the reason why they're segregated, or that the hot X-ray emitting matter is in the middle, is that that's dissipative matter, that the gases collide,
Mhm.
so they stay in one place, after having collided, whereas the dark matter can just pass through.
Exactly. Yeah. It's self-interacting or not, so that's what, sort of shows the different kinds of matter, the differences between normal matter and dark matter.
Yeah.
But it took scientists think that there's dark matter throughout the galaxy, but it takes a super violent event like this to sort of dislodge it from its host.
Hmm. And then you also showed a picture of the galactic center
Yeah.
in your slideshow, which is actually looks pretty new. I know you have a lot of radio in there, but so
Yeah.
maybe you could explain that. I know all the colors are corresponding to different things.
Yeah. So this one is, so usually, we have a lot of Chandra only images of the galactic center. This one does have, I believe it's a meerkat, which is a
Hmm.
radio antenna in Australia and South Africa. So yeah, it's kind of a jumbled mess, but you see these sort of like long streamer type things that are in front. Um, those are, sort of streams of radio waves that are sort of parallel in our line of sight to the galactic center. But buried within one of the bright circles, and the one onto the right, I believe, is where you'll find Sagittarius A star, or the 4 million solar mass black hole at the center of our galaxy. And so Chandra and other telescopes over the years have looked at this region in depth, and every time you look at it, you see something new. So it's really, I mean, the analogy that you guys have probably heard before is that we're sort of in the galactic suburbs. This is like the bustling downtown, and there's a lot going on. And you really, to get the real sense of it, you should look at it in different layers and different pieces. I think it's just kind of pretty, but it's hard to sort of piece together exactly what's going on because there's so much happening. I mean, there's, you know, stars that are sending out powerful winds that you see those in the X-rays, you see supernovas going off, you see all sorts of stuff happening. It's a big mess, but it's our mess. And there is a giant black hole in there. So lots to learn about the galactic center still.
Yeah, still. And it's oddly quiet in X-rays, isn't that correct? Oddly
The
weak
currently,
emitter.
yeah, currently Sagittarius star isn't super active, though we've seen it flare over the years. It's not flaring the way that you see like an active galactic nuclei, or it's not feeding, at the rate that we see other supermassive black holes feeding. That's probably a good thing. It probably means that things are pretty quiet, relatively speaking, for our Milky Way right now.
Mhm.
Maybe because we're a mature galaxy, and most of the stuff that would fall onto the black hole to feed it and make it produce outbursts have already fallen. So we're kind of in a quiet period at this point. But yeah, compared to other galaxies, it's definitely, or this black hole is pretty chill.
Pretty chill. Um, and as far as Mercury is concerned, there's no Chandra data on that. Is that correct?
No. That's one we can see some Chandra, we have Chandra observations of some solar system objects. We have some uh, Venus, Mars, Jupiter, Saturn. But you cannot point Chandra too close to the sun. And so I
Right.
don't think we could ever get Mercury because it would be too chance it would blow out the instruments.
Right. It's with uh, Mercury's always within about 25 degrees of the sun.
Yeah.
So, oh, Michael.
Yeah, just a real quick question, Megan. Was Chandra one of the wavelengths involved in that really great multi-wavelength shot of Messier 104?
Yes.
Ah,
The anomaly spiral arms ones. Yes, we took that. We're one of the telescopes in that one.
cool.
What's the NGC number? Michael, do you know?
104, the sombrero.
Oh, the sombrero. Thank
Oh,
you.
the NGC, I don't know. No, it's
Well,
Messier 104.
the sombrero is helpful. Um, hmm. I don't think I've seen that shot, that picture.
I mean, I think
It's
the
a
thing
nice
with
shot.
I think the thing that, Chandra has shown, at least over the past 26 years, is that you really do you need to have all of these different telescopes working together, ideally, in order to get a full picture of things. And so, a lot of the X-ray only stuff is a little abstract. Some of the stuff is beautiful on its own, but a lot of it's kind of a little abstract, blobby art if you squint. Um, but then you realize they composite these things together with other wavelengths like infrared and optical, and you can really see the other features, and it kind of makes it more complete, at least to me. Um, and it looks a little bit naked if you take all these layers out. So I mean, my hope is that we can continue with this multi-wavelength era that we're in, um, and explain that there is a need to have these different types of telescopes because they're not redundant, which I think some people might think is the case if you don't know what astronomy is all about.
Hmm.
They're really complementary, and they show different pieces of the puzzle that you want to learn about.
How is Chandra doing?
It's doing remarkably well for being in space by itself for 26 years. Chandra was never, way back, like before launch, before it was built, it was going to be serviceable, like by the shuttle, the way Hubble was. But as we are now, their budgets changed, and they had to totally rescope it. And they instead put it in this very highly elliptical orbit that takes it a third of the way to the moon, and then back through, I think it's about 10,000 kilometers. It's the closest approach. The good news about that is we're not in the radiation belts very much for most of the orbit, and you can't observe when you're in the radiation belt. So it degrades the sensors. So that's good. The bad thing, of course, is you're never going to touch it again. So it's been on there on its own. There's some issues with where you can point it, so you don't want it to get too hot, and there's some thermal issues, but the engineers have figured it out. So right now, knock on wood, it's doing really well, and there are no expendables on board that will cause it to, it doesn't run out of coolant or anything. There's nothing like that, or fuel. So, I mean, it would, but it has so much on it that that's not an issue. It's really just being in space by itself. So far so good.
So I know it's a great imager, but what's the best X-ray spectrometer in space now?
It might
XMM?
be maybe XMM. Maybe, and there's also like eRosita that launched, which is a German.
Hmm.
Um, and that's a good question. Probably XMM or one of those, or eRosita, I think.
Yeah. Boy, they sure can pick up a lot of elements in the supernova remnants.
Yeah, but Chandra has some has a couple of gratings on it as well that they
Hmm.
can use in addition to the imaging instruments we have. So there are four instruments on board, so you can use them.
I've always been really impressed by the energy resolution of Chandra.
Mhm. Yeah, I mean, it's done. It sort of had to be a jack of all trades for X-rays for a long, long time. So hopefully we can get a replacement going at some point, but we'll see.
Mm. What's being planned?
Let's see. Well, I mean, there's proposals for what's called the Lynx Observatory, which would be sort of a bigger, better version of Chandra that had some other, um, sort of spectroscopic and imaging capabilities. But that would be, we're in this there's the decadal survey, and it was not picked as the next decadal. So it might have to be reconfigured to fit into what is NASA, at least last year, was calling the probe mission, which is a smaller but still not tiny mission. So there are lots of ideas about how to sort of take X-ray astronomy into the next phase. Nothing is solidified at this point, and of course, nothing's solidified in lots of aspects of what's happening in space science right now. So um, hopefully, there's consensus and there's some decisions and all that sooner rather than later. But we'll have to wait and see what happens with NASA and other agencies.
Yeah, topsy-turvy times.
Hmm.
Um,
Very true.
are there any were there any collaborations with Europe for an X-ray observatory?
Yeah, so there's I feel like, astronomy is inherently a very international uh, field. And, on Chandra, for example, the low energy transmission grating was built with collaboration with people in the Netherlands. And so the European Space Agency is working on an X-ray telescope. So XMM Newton is an X-ray telescope that ESA runs. There's a lot of overlap, between like Chandra and XMM. So there are collaborators who are in Europe for that Links project I mentioned. There's what's called New Athena now, which is going to be hopefully the Europeans' next X-ray mission, major mission. So there's a lot of crossover. It's really not an either or. It's more of an and when it comes to people working together. At least that's how it's always been for, there's been a lot of, involvement with the Japanese Space Agency as well.
Mhm.
They have, they're in X-ray astronomy quite a bit, and have a couple of telescopes up now. And so yeah, I mean, there's lots of different places and, that can, different ways to keep the field going. It's just, would love to see the NASA be still at the forefront.
So with this book almost out, what are your thoughts on what you might like to do next? Are you going to try a different age group or
I don't know yet. That's a good question. We'll see how it goes. I mean, the books are very much sort of, they're my side projects. They're sort of in they're in books I didn't know this before I started writing them. Um, they just have a really long lead time. And things take forever, and
Mhm.
um, so it's always nice to have them in the background. And so,
Right.
then I spend some time and work on it, writing them and whatever, sort of in these spurts, and then I don't know, it'll come to me or Kim or whatever, and we'll figure out what to do next. But we'll just usually it's one at a time. We'll see how this one plays out, and see what kind of energy, life source we need to try the next thing. But we'll come up with something. We usually do.
Are you
Oh,
self-published?
Tony has his hand raised.
Oh, so maybe could I pose one final question both to you, Megan, and to Bill, as both as authors? What would you suggest as the biggest or most couple best tips for someone who might want to eventually write a book about what they love?
Do you want to go first, Bill?
Uh, for me, it's always the title. If I've got the title, I've got the book. I know that's a silly statement, but it's
No,
true.
no, it makes sense.
I
Uh,
love that. Yeah.
and then the organization. If you find in your head that it's amenable to some sort of organization, chapter by chapter and section by section, presuming that it's a nonfiction book, uh, that helps. If you find that it's lends itself to an organization that people could follow and appreciate, that's helpful.
Thank
Yeah, and
you.
I would say that, it depends. If someone asks if we're self-published, and no, I've always had all the books I've done have been through publishers. And that's a different beast altogether. You know, I
Was your first one through a publisher or was that self-published?
what's that?
Was your first title through a publisher or
Yeah,
through?
it was actually. So the way that we got into writing books at all, and Andy will remember this. In 2009, it was the International Year of Astronomy, and Kim and I worked on a big project that brought space images into like public parks and train stations around the world, and we wrote an article about it. I think for Sky and Tell. I don't remember exactly. And an agent read the article, and was like, "You should write a book." And I was like, "Yeah, whatever." I was like, "No." Yeah, that's like the last thing who would do that. Like that's like running a marathon. It sounds crazy. But we talked more about it, and she was really like encouraging. She was also wanted to have more female voices in astronomy and science books. And so, we after initially rejecting the idea, we decided we'd give it a shot. And so, my advice would be if you want to go with a traditional publisher, is to find an agent because even though you totally can self-publish, it is a really hard thing to get eyeballs onto what you've written. I think unless you know social media or whatever better than I do, which is easy to do because I don't know anything. Um, so it was that agent who helped, they shop around, you write a proposal, they shop it around to different publishers, and then you get the book published. And that's how that's obviously an oversimplification, but they're the ones who can approach the publishers. I don't know if many publishers take cold calls from um, we were unknown authors. So my first book was with Smithsonian Books. We've worked with Black Dog and Leventhal, which is part of Hachette. And I did an MIT Press book. I did one from the University of Alaska Press. There are academic press books out there they're a little bit easier to break into. They don't have as many resources as far as marketing.
Mm.
That's not important. It depends on what you're doing. And this current book is with Source Books, which is they do a lot of like nonfiction kid stuff. So I don't know. I am still learning about this whole field, having done this since for 13 years now, I guess. It's changing, as the book world changes too. So I'm not sure I have super great advice, but maybe find an agent if you want to not self-publish. That might be my best piece of advice.
How about a graphic novel, Tony?
So actually, I think the first semester that I TA'd with you, I proposed the idea of like teaching a course entirely just from like HST images, like couple images.
Uh-huh.
And I think that would be amazing, like teach astronomy through images, and it's the perfect medium for it. So,
Very pictorial.
yeah. No, thank you so much, Megan.
Oh, sure.
So, have you ever thought of doing video projects? You are in a group there at in the Chandra X-ray group at the Center for Astrophysics. Would you be able to muster what it takes to do a video?
Well, we do videos for Chandra, different, we do video podcasts, and we've done some short films and all this stuff. Are you talking about like from like on the side, like the books?
Well, something which would invoke your creativity.
Um, you know, that's more like yes, I would love to do something on the side. I have to sort of keep a wall a bit between like the Chandra stuff and then the book stuff because
Hmm.
that's done on my own time versus I obviously get paid from Chandra. So at some point, sure, I'd be open to doing more of a creative video type thing. But you have to again, I think there's a lot of heavy lifting in those kinds of things. So you'd probably want to find the right partner to do that with.
Somebody who knows how to do that stuff.
Exactly. There you go. Like I know some things, but I definitely don't know everything. So I don't know how to do that stuff very well. But
Yeah.
video production is a bigger thing than what I would know how to do.
You could do it like Ken Burns
Yeah.
with lots of scenes with muskets.
Yeah, that would fit the astronomy thing. Let's do that.
All right. So I've run out of questions. Any other questions here? I think we're good. Well, Tony, congratulations on your Aurora.
Great job.
It was a
Spectacular.
delight to be able to see it. I'm so lucky.
Yeah, yeah.
Beautiful.
Good luck. And we're not done with the sun. Got another year or so before it gets dim or less active. And then
Why are
Megan, congratulations on getting this book for our future.
Well, thanks for having me. It's been fun. Thanks for indulging me and listening to my spiel about why we did this, and hopefully you guys thought it was interesting.
Yeah.
Thanks for the presentation.
You're
Thank
welcome.
you. All right. Patty, do you think this is time to call it quits?
I think we're pretty close to that time. Yeah.
Okay.
Of course,
All
it's
right,
up to
then.
you, Bill.
All right. Thank you all.
Thanks,
And
everyone.
Thank you
Bye,
very
Bill.
much.
have a
And
good
thank
Have
you,
a
evening.
great
Megan. This was
Thanksgiving.
so nice. I really appreciate it.
Thanks for having me. I appreciate it.
Good seeing you all.
Good night, everybody.
Bye.
Bye-bye.